Alright, looks like we're nice. Okay, so before continuing on the book to chapter 11, I want to do something first. Okay, hold on a minute. Okay, I want to do something first, and that is trying to implement this, the length function. Okay, let's start this out. Oh, right. Before implementing this function, I kind of want to try, putting this into a macro, because I want to reuse this expression. Okay, I mean, maybe we can use that as a integer overflow mechanism, Should I do this in here? Let's see. Call it max bit size, I guess. And there is, and this is, what should I use, type or value? I mean, if I use type, let's name it type. Alright, and then let's do something like this. Size of type can we do this? Type it, okay. Negative 1. Let me run. Okay, it works. Okay. Max bit size. Value count. Should we add maybe First use undeclare. Alright. And then you know what? Let's use the debug function gdb scripts. What is it called again? Start, no, okay. Print. No symbols are big in current context. 34, okay. Let's add a breakpoint. 934 and I'll continue. Guess 69 print. Value count 31st, okay. So if I change this value count to, let's say, this one. Okay, we got integer overflow here, so let's try, wait, no, not that one. Okay, and let's continue. Value count got integer overflow. Okay, and then let's commit that first before we are continuing. Yes, no, okay, not that one, but this one. Wait, what did I want to token? No, not p type. Define. Oh, macro, I guess. Not define. Okay. Macro expand. Okay. Size of in. Alright. I guess that kind of look the same. Like this one, right? Let's commit this. Refactor. max bit size. Macro for integer overflow checker case. Mechanism to get the max speed. The integer overflow mechanism. So let's try using macro and see how it goes. Alright. Untuk another to do. Okay. Let me copy. Let me open this. So basically, what we want to create. Let me put this here. Basically, what we want to create is, I guess, something like this. Right. We want to evaluate the code expression. But yeah, this is the length for the symbolic expression. But in this one, the function length returns element in quote expression. So let's try implement for the quote expression first. Where is it? Where is it? Right, okay, alpha. Oh, this one. With inline, okay. So the return value be alpha to I mean, let me check how to put in list. Oh, it's just changing the type. Okay. I mean, we have count, right? So maybe we can use that like returning the count. The built-in this one. Lisp in Lisp, and then okay, we used in here. Alright, okay. And then after we got this one, we return the value, right? Scripts. This one and then print on. Let me check. Alpha print. Okay. Expression. It should be, I mean the count is integer, right? Okay. I mean, let me try a case. Is it in Lisp? Oh. Let's try this out. okay. Print value count 1, okay. 69, 42, 69, 42, 0. Print 3, right. So we already got count. Okay. Value count break. Right. You know what? Let's example this one. Value count 3, because we are stopping in the this one, the return list. Let me delete this and let me stop in this. The line 69. What a coincidence. Okay. Print value count 1, okay. No, we cannot do that. Type. Okay. Type, okay. Continue. Yeah, I'm not really sure yet the print mechanism. I mean, if we do something like this, right? 69. Then we need to be able to provide the length of the code expression. We already got the count, right? Start level value and then right. Certainly. Okay, I think we should what is it called? We should add expression, right? And then we need to allocate the size of, we need to allocate the value. This is kind of tricky. What should we return? When we are printing that out, right? Value count equals 0. Right, we change the type to, right? Become this one, and then so if expression type equal code expression, right? Then we can do something like this. Okay. Count. Plus equal count. Right. We add the count from the code expression to the value count. And then free this count built in say get deleted error. Okay. Oh, okay. I mean, in alpha take, if I remember correctly, oh, this one, we also delete the value, right? Or in this case is maybe calling this value, but then calling this item or total, maybe value equal total. This one change the value. And return total. Maybe I still have no idea. Well, that's the point, right? Trying things out, and see how it goes. And then, I mean, yeah, I'm not sure if that mechanism can be used for this, right? I mean, in this if no, not that one. But in if first take, okay. one. Well, let's try something simpler first. Same, okay. Return built-in. What is it called again? Not handle. Okay, where is it? 5 to 8. In the taillight. I mean, let's just break, I guess. Scripts. Okay. Okay, something is wrong. Okay. Three, 4, 5. Okay. Pre-utils 3, 4, 5. And 69, 42. Print value type. Oh. Interesting. Continue. Okay. Now what would happen if we use this? That's not how I expect that. Yeah, so what is the problem? Built-in head. Hello, welcome agents and Liz. Okay, we are trying to learn C at the moment by reading this book. Let me copy this in the chat. And I'm currently trying to implement this, the length function that return the number of element in code expression. And yeah, I'm still not sure how to handle that. Oh, wait. 69 print value cell. Oh, okay. We need to calculate the cell one. I'm trying to learn C. Right? C programming language. If you didn't know yet, it's basically, what is it called? Another programming language, right? C is a programming language, and we learn this programming language by creating another programming language, I guess. It is Lisp, or a simplified version of Lisp. Lisp is also another programming language, and I'm not really familiar with Lisp. Let me copy this. I'm not familiar with Lisp, but we are trying to create the interpreter for Lisp. If you ever try, let's say, Python, right? We can do something like this, and this is what we are currently creating, the interpreter for Lisp. Okay, hello pseudo tensor. Where are you from? I'm from Indonesia. Okay, hello Nanan and Yuki. Welcome. Okay, I'm currently trying to learn C with this book, right? Maybe let me copy this again in the chat. And currently I'm trying to implement the length function to check the number of elements in quote expression. Basically, we have this quote expression, something like this, right? In our example, in our Lisp implementation, the quote expression using the curly bracket instead of the single quote. So this is the quote expression, and we can also try to do this 6942 and we get the quote expression, the first element from this quote expression. That's basically we are trying to do. The press pro by. Okay, thank you for coming. See you next time. Pseudo tensor. Okay. Now I'm. Let's see. Okay. The interesting part is that. Okay. With this head implementation, right, we are actually, if I remember correctly, okay, pop, we are actually, okay, we moved the, what is it called? We moved the memory, I guess, like we resize. Is that it? I kind of forgot what memmove does. Copy memory. Copy memory area. Okay. Copy from the I. And then move it from destination to, what is it called, N, or the source, I guess. So this is the destination and this is the source. Okay, and then realloc this. Yeah, this might be trickier than it looks. Okay, so value cell, okay. Let me check. Let me try. Okay, count, right? First thing first, we only passing. Oh, right. This can be. What is it called? This can be dangerous if suddenly count spike to more than one, right? For some reason, so maybe we should use this instead. Maybe, but yeah, let's try it out. Excuse me. It's been cold lately. If count more than, sorry, this should be more than one, right? But what about 0? Right, head, empty list. Was empty list. Okay, we already handled that. So head count more than one. Okay, that. I mean, my concern is that at some point maybe the count can suddenly spike up into wait, even though it is spiked up more than one, right? It should not be a problem because it is not one. Let's say the count become 2. Value count, if I can type, become 2, right? This will also fail. But can count become -1? And even if count suddenly become like this will also be true, right? Okay, yeah, I think that should be fine in this case. Pass too many argument and pass too many argument, and then value cell the type, right? Not equal. Okay, now we are checking this one again. Pass incorrect type, right? Equal 1. Put in name empty list. Okay. And then should we allocate new memory to? That's the question, right? I mean, with that, we didn't really. Oh, wait. I think we create the new memory with this one. This is the destination. Okay, So if I understand correctly, what is it called? Copies and bytes from memory area source to memory area destination. The memory areas may overlap. Copy take place as though the bytes in source are first copy into temporary array, right? That does not overlap, okay. And the bytes are copied from temporary array to this. So basically there is this three what is it called? Three space, I guess. The source, the temporary, and then the destination. So the source copy from the temporary, and then temporary copy from the destination. If I understand correctly, that's what memove does. Now, oh, so wait. So does that mean we also allocate the new memory with memove? I guess let me verify that. Memove allocate new memory. Save memory moving with practical example. What? Okay, copy this one, right? This is the destination, this is source, and well, this is the string character, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, and then null terminator 4, so 14. Including null terminator, right? Source destination. Oh, okay. No. Only move to memory then. Right, because we already have this memory in cell. Okay. You know what? Let me check this using GTP. Okay. Expression noun gibberish. And then this is another gibberish. Okay. And then let's 69. This is just another gibberish, I guess. Okay. And can we access this memory address? I guess we can do something like this. Oh no. Cell. Okay, we cannot access the memory. Now that make me kind of curious. Okay, looks like we cannot do that. We have cell, right? Now how do we do that? Maybe, right? Maybe we can use move too. Print receipt, this one, right? And can we access? Oh, for some reason it is the same. Interesting. Yeah, the second one should be invalid. What is that? I have no idea. Okay, yeah, I mean, maybe we can move that to the index 0, right? Like the count is 1. Okay. Other than creating a new one, but zero. Wait a minute. Okay. 69. 6942. Okay, print value count 1. Okay, but the type symbolic. Okay, and then right. The count is 2. Okay, interesting. Cell 69. Okay, offset 1 4 in 6942. Where is the 42? Oh, in this one, I guess. Right, okay. Alright. Well, let's take a break first, I guess. Cell and then okay. So we move that into the count, I think. What is Lisp? Lisp is another programming language. Basically, well, it is abbreviation for Lisp processing, I guess. So imagine we have a list and then we are processing those lists or evaluating those lists. For example, well, like this. Let's say we have +1 and then 1. We are evaluating this list to give a result 2, something like this. So yeah, we what is it called? We think of the programming language like a collection of lists, I guess. That's as far as I understand. I mean, I don't really understand Lisp myself, so I just want to learn C, and C, again, another programming language. So we are kind of learning 2 programming languages, but the primary programming language that we learn is C programming language other than Lisp. I honestly have no idea if my Lisp interpreter is correct or not, right? So there is that. Okay. Try Rust? Not now. I want to learn C, Not Rust. Maybe next time. Let me go to the bedroom first. Be right back. Don't forget to drink water. Alright, well, let's continue early, I guess. Okay, if the count is not 1, too many argument, okay. It's not quote expression, okay. If the offset 0, count is 0, we pass empty list. Alright. Now, what should we do? Maybe we should write the value, right? Where is it? The value alpha here, right? Cell count. Maybe we can increase this. So, yeah. Then creating this one. But do we need to move the memory down? I feel like we don't need to move the memory, right? So, okay, not okay, count equal to, alright, so I don't think we need this one, and well, let me change the value type. Okay, type to alpha name value count, I guess, plus value cell 0 count. This can have an overflow. Well, everything can be overflow. Yeah, maybe we will handle that later on. And then we return to... Oh, wait a minute. Pass empty list, okay. Should we return this error? Like, I mean, I don't think we should return this error, you know. Because we are lang, right? Just print out 0 or something, right? So if that's the case, maybe we can do something like case alpha. Okay, value count equals 0, and then this one return to value. Okay, there is no total, right? Value. Let's compile that again. Compiling. Okay. Classic, right? Classic. Okay, let's check that out. Where is it? Let's this one. Okay, run. No, 69 2. Oh, okay. This is not expected. 0. Okay, this is expected, right? Yeah, because count start from 1, right? I mean, let me add breakpoint in this one. Break utils 365. Okay, and again, and 69. Okay, step I guess. Okay, now we are in this line. We haven't executed that line yet, so let's try print out count 1, right? The count is 1 by default. Okay, so that is the problem. If value count if value count if value count equal 1. So the point is that when we have the value count equal this one, maybe starting from 0. If value coin, I guess not equal, but yeah, there's maybe there is a case that this logic will be wrong, you know. Yes. Debug. Where is it? Run. No len. Okay. 3. That is not expected. Okay, maybe so do something like this, right? If the cell or the child is not 1, then yeah, let's just adding those 1, but it will be easier like this, maybe. Okay, 1, 2, okay. I mean, let's see if I can do this. Right, 42, 69, 3, Lisp 6942 0 4. Okay, so the list is not evaluated. Okay. I don't think that is correct, but yeah. 3, okay. I mean, this one should turn into, what is it called? Into 3, right? So with this expression, I assume we need to have, what is it, 7, I guess. This is 1, no, oh sorry, 6, I think 6, 69, 42, and then another 42 from head, formulating head, and then this one, Lisp result in 3. So this is not correct yet. Okay. I mean, value count 0. How do we evaluate that? Should we like using recursion? Let me think. We have cell, right? Just copying the count is not okay. let's put this in this. No. At the break in the line. Alright. Let's just this in the line. This one 353. 353. Okay. Print value. You know what? Let's check this out. Okay. Symbolic expression count 1. Okay. And then we check the cell, right? Okay, we need to dereference again. Code expression. Okay, another cell. Let's check. Okay, 69, right? From this expression, maybe let me put this in here. Okay, and then cannot access again. Not this one, I guess. This one, the offset of this one. Right, okay, 42. This one, okay. Then this one. Count 2. Interesting. Do like this. No. Don't think that's it. Cell. Okay. Head. Okay. So this one is storing for the head. Okay, let me. What is it called? Let me. Not that. Okay. This is for 69. This one, right? Okay. 69, and then the offset of this one is for the 42. Okay. This one 42. And then the offset for this one is for the head 4269. If my assumption is correct, okay. See, this is the symbol, right? Head. What about this one? Cannot access memory, okay. Nope, not this one. I think we need to go deeper into the cell. Oh, the cell is null. The head. Alright. Or maybe we should use eval, you know. Yeah, like eval. Eval, okay. Something like this. Print value cell, right? Okay. For okay, let's continue. Cell with offset cell. Okay, 69. This one is 1. Okay, another offset 42. 2. Okay, we have this symbolic expression. Count 3, and then cell. Now we can also just do this. No, nope, that is not possible. Okay, eval, right symbol, okay, and then cell again. Assuming we can access this memory address. Nope, we cannot access that. Right, cell. Previously like this, right? Oh, sorry. Okay, this is a file. Let's check. No, we cannot access that. We cannot access that either. Okay. Wait. Hold on a minute. Okay, let's check this out. Head. Okay. And then, yeah, let's check this out again. No. So we cannot. Oh, okay. I think cannot access. Interesting. Head. And we got this one. Wow. So why this one is not evaluated? Yeah, I still have no idea. We can just copy the count, you know. We need to evaluate the other expression. guess we are just using this one, right? The alpha take. Then item. Are you writing a REPL or do you just read a Lisp file for now? For now, I'm writing a REPL for Lisp, something like this. Yeah, for now we are only writing a REPL, not reading a Lisp file yet. I mean, I'm still not sure if we get there. I'm kind of confused, right? I guess. Okay, and if count more than one, I assume if we have this, what is it called, the symbolic expression, I should be able to evaluate that too, right? How to do that? Oh, that is usually called car, and then is called GTR. Oh, okay. Yeah, I mean, I don't have any experience with Lisp yet, so it's kind of, what is it called? I kind of learned two different languages, I guess, C programming and Lisp. So yeah, then there are variation next CRTR, which is the head of the car of the CTR. Yeah, it's getting more complicated, right? But you know, I want a simple Lisp interpreter, not this proper Lisp interpreter, I guess. I mean, my goal is to learn C, you know, and learning Lisp is just a side effect, something like that. So yeah, and currently I'm kind of struggling implementing the length for the quote expression. I mean, I'm following this book, right? Where is it? I'm following this book called Your Own Lisp. Again, the goal is to learn C by building Lisp interpreter, something like that. But yeah, the goal is learning C. The Lisp stuff is just a side effect. And now I'm confused. How do we implement this? Implement the length when we have this symbolic expression. Oh, right. In the book, we are using the curly bracket, this one. the curly bracket for the, what is it called, for the quote expression. And if I understand correctly, right, like this one, the quote expression in Lisp using single quote, something like that. So yeah, I mean, I'm able to replicate this, right? Let me demonstrate that. List, right, at least 69, 42, 69, the 0. So yeah, but if the symbolic expression is inside the quote expression like this one, I am still not sure how to handle this. Quote is quite simple. The same as okay. This means I simply don't evaluate the body of the quote. Alright, don't evaluate the body of the quote. Okay. But how would you write that is the empty list? Okay. That is the empty list. So if we have, let's say, something like this, quote 1, 2, 3, and then another, what is it? Symbolic expression, I guess. Symbolic expression and using head, for example. Head. Is this correct? Head quote. Head like this. A, B, C, maybe. Do we evaluate this first or just print this as is? I mean, well, let me try, I guess. What is it called? 69, 42. Oh yeah, let me copy this instead. Okay. So we are printing that as is, not evaluating, huh? Okay. So maybe that is correct. Am I overthinking? Right. I mean, right, we didn't evaluate the quote expression, right? But yeah, I mean, if we do something like this, then sure we evaluate the expression. Maybe I'm doing that right. Who knows? Okay, you know what? I can put this in here, right? This is for the empty quote expression. And then for the count, yeah, let's do something like this. Okay, count else value. I guess you could just do with the empty list, but what about okay, so because we are using the curly bracket as a representation in our lips here, so instead of using the single quote like this, we are creating like this, 6942. So if we, let's say, have this quote expression, right, it becomes something like this, curly bracket. Yeah, I mean, from this chapter 10, right, instead of using the single quote expression like the common lips, we are using the curly bracket to replace that, which unique to our lips. Okay, so if it is empty, yeah, it is empty. Let me check this first. Is it on print none? Oh, it's in this one. Okay. Let me. Yes. Okay, scripts. Okay, yep. I don't really want to print the empty curly bracket like this, I guess. So main debug. Okay. Alright, in case anyone want to check, you can check on my Git repo here. Let me copy this in the chat. Oh, okay. So return. Okay. Alright. It looks like my implementation. Okay, so the curly bracket should return the empty list. Okay. Alright, so let me check. Where is it? This one. I mean, let me compile this again and run this. Okay. If we are not, what is it called? If we are not putting anything, it should return empty list like this, right? And then if we, let's say, put this curly bracket should return like the empty list like this. Is that it? If that's the case, then okay, maybe we can change that. With this eval expression. Butcher, okay. So I butcher open, okay. But then if we, let's say, using this, it should print like this. Okay. So I need to know what I need to know again. The print, like the print expression. I mean, like the value, right? The value of the print expression. Is it only 1 or 0? Right. Let's use GTP to evaluate that. Scripts, and then we add breakpoint in the 471. Okay, run. Alright, and then let's try this one. Okay, print. Okay, we have this one, count 0. Alright, count 0. So every time we have the empty expression, okay, yes, what you have now is, okay, it is incorrect. It should be, okay, it should be quote empty list and then return empty list. Okay, okay. So every time we have the count 0, okay, we need to return the empty list. Okay, so alpha. Alpha print. Should we use alpha print? I feel like we don't really need to use the alpha print to print an empty list. So yeah. And so it should be like this. Okay, I think that curly bracket 69 is incorrect because in actual. Okay. Yeah. No worries. I mean, I don't have any experience with Lisp, so I'm not sure what is the actual Lisp implementation, and if possible I want to replicate the actual Lisp implementation as much as possible. I mean, yeah, using the single quote might be harder to implement rather than using the curly bracket to enclosure the quote expression. So okay, let me print this one, something like this, right? For expression. Okay, and now, yeah, let's just quit this. Let's try this. Okay, this should return empty, right? The expression, but yeah, this one, maybe this should return, the curly bracket should return the, what is it? The bracket. Okay. So I think we can change that in here. If that's the case, then maybe I can just do here, do something like, because if we are gonna print out the bracket, right? Instead of the curly bracket, we can use this expression. Let me check that out. 6942, right? Okay. Is this what you mean? Right, so you're basically, what is it, printing something like this, right, in the actual Lisp, I assume. Yes, exactly. Okay. Alright. Okay. At least we know what it looks like in the actual Lisp. I mean, again, creating an interpreter without actually know how the programming language works is kind of reckless. Let's put it that way. So yeah, again, I'm not sure what is the expectation here. Right, I'm basically learning two programming languages at the same time. Thank you for the feedback. Lalu, okay, maybe let's commit this first, right? Wait, let's try this one. Okay, it also 69. Great way to learn, actually. Yes, I mean, like, because I'm implementing this, I kind of need to know how Lisp work. Like, should we evaluate this or not, and something like that. So it is a great way to learn, but not the easiest way to learn. So what is it called? The hard way, right? The hard way to learn. Right, that's what I do, I guess. But it is fun, you know, like, I learn a lot doing this the hard way, right? So yeah, again, it is a great way to learn, but some people might find this confusing. Okay, let's try this one. I mean, can we like try this one? At least, what is it called? 42, 69. Okay, yeah, I'm just confirming. 69. Okay, yep. We did not evaluate the code expression. Okay. Again, I'm not sure if this is the correct implementation. Like double what bracket like this. Okay. Anyway, let me commit that first. Where is it? Okay. This one, right? I don't put. Okay. Let's commit that first. This one. Okay. Put that in a new commit. Git commit. Okay. Refactor utils print out if evaluate empty list it seems like in the list, in the, what is it called, General Lisp implementation, if I can type, implementation, when we evaluate the empty expression like this one or this one, or the, or our code expression like this one, okay, the curly bracket, we need to print out the empty bracket like, okay, so let's change that. So let's try stay close to the General Lisp implementation as much as possible. Implementation as much as possible. Alright. As a function application, for example, applying head should look like this. Oh, okay. Yeah. I mean, our current Lisp implementation can exclude the, what is it called? The list, right? So yeah, I guess you might be right. This one, right? It's actually the same as this one. It's, yeah, I think this is not correct, so maybe I will fix that to use the bracket, right? Okay, one by one, step by step. So let's try stay close to the General Lisp implement. Oh, right, I want to ask if somebody, what is it called, if somebody like having this expression, without the bracket, right? This one without the bracket, what is the error message of the, when some user using this expression instead of the symbolic expression like this? Is it syntax error or, yeah, I'm not sure yet. Let's try cycles. Okay. And then we change this one, right? Okay, this is quite tricky to commit. But let's try this out. I think this should be, wait, minus, okay, and then this should also be minus because we have this empty line, right? So we delete that too. Okay. Nope. Let's check. Okay. Okay, alright. That's good enough. Okay, commit. Wait, what is the... Where is it? Refactor, okay, yeah. I thought that I use different keyword replace refactor utils. Print out the same expression for what is it called? Expression and seems like in general Lisp implementation we okay, we print out the code expression using the bracket, using the bracket symbol, I guess. Using the bracket symbol. So similar to print out the bracket symbol, similar, not the print out, I guess, similar to how we use symbolic. Is symbolic expression sample when we use symbolic expression we need to give the, what is it called, the bracket, we give the expression we need with surrounding bracket like 16942. So when we use the code expression like 16942, we should print out the expression like 16942. Okay, well, and then okay, in read, right? In the read function. This one maybe. So if it is the root, tak is the root, we basically, what is it called? We declare that as the symbolic expression. That's why we don't really need the enclosing bracket. Alright, that is the, I think that is the word, right? The enclosing bracket, where is it? With the enclosing bracket. Okay, let me amend that. Enclosing, right? Enclosing. Let me check if the okay. Enclosing bracket. So we use the okay, so if we want to return an error, right? Read sim alpha sim. Okay, alright. If okay, and then we return alpha error. Lib should start with enclosing bracket. Get like 6942. Let's compile again. Let's run this in here. This should be an error. Okay. Lib should start. Oh, let's ignore this one. Should start with enclosing bracket. 69. Oh, okay, interesting. Interesting. That is not what we expected. And yeah. Okay, so that is not what I expect. How do we... what is it called? If the tag, no, it's... I think it's not the tag. Let me copy this first. Yeah, I think it's not the tag, but what is it called? The symbol. Well, let's check that out in GDB. Okay, GDB, right. So if I try to invalid in scheme. If delete, get this. It's actually correct. It's being validated as two spirit. Oh. Okay. Result. To symbolic expression. Okay. To spirit. Alright. Then return. Then return. Oh. Okay, so we don't necessarily start with the enclosing bracket. The same as writing first head and then return. Oh, like head and then return and then this one. 69 52. Then return. Oh. Okay. So the problem is when, for example, if you just add as a procedure. Oh, okay. So we are not executing, what is it, on the next expression. You don't necessarily start with, okay. So, I mean, if I understand that correctly, when we use head, it's like, what is it? The REPL waiting for another expression, right? For example, this one. And then we hit enter again. It will print, what is it, 6942. And to apply a function. Oh, if I want to apply a function. Okay, so alright. So it's not like this. Okay, head, because head is a function, right? So if we want to apply a function, interesting. Yeah, how do we do that? Like the different, like, now what you have is correct. Just head should, and it should return head, or something like, something like this. And let's change this to should not apply to head to, okay, procedure processor head, something like this, right? So this is, let's say, clips. This is clips, and then this is a subprom, I guess. We have another subprom. So processor head like this, right? Oh, the means that it takes one arc. Should not apply head. Okay, and then we print this. Okay. Currently, I'm not sure if I can implement this procedure sub prom, I guess. Yeah, I am not sure how to implement that. So the printing head is correct and enough. Means that it takes one argument. Okay. Yeah, maybe the easier what is it called? The easier mechanism is, so we should not evaluate the head, but just print what, like, let's say we have this clips, head 6942, for example. The result should be like this, head, and then 6942. Oh, sorry. The result should be like this. Is that what you mean, Lalo? I mean, again, I'm not really sure how this works, right? Okay, if this is this might be more visible than implementing this one. The procedure what is it called? Subprom. Okay, let's okay, maybe we should also print this with the curly bracket, right? Wait, one step at a time. Okay. There is the version. It should be passed as two different symbolic expressions, and the result should be two lines. The first with only head, and the second with. Oh, okay. Okay, let me commit this first, I guess. Line 3, and then this one is 4. Wait a minute. Okay, let's try handling that after this one. The length, is it called 6942? I feel like that is too. Like that is too long. line 1642. Okay. Alright. Okay. Break. Count. Okay. But yeah. Do we need to like free the memory of cell? I happen to deal a lot with Lisp because I'm writing a text editor in C. Vulkan and Scheme. What Scheme is embedded and the extension. Oh, you are writing a text editor. Okay. That interesting. Maybe you can share the project if it is already on the remote repo. You know, I'm still not confident enough to write my own text editor, you know. Again, I might struggle just building a REPL, let alone a text editor. But hey, one step at a time, right? Okay. Yeah, maybe we need to free the memory, right? The memory of this one. Alpha-tail, okay. See, we remove this one. Break, okay. Maybe we can also use this. But the value count. And it changed. Well, let's try that one out first. No, not script main. Scripts, what is it called? Line 6942, okay. Okay, yeah. We cannot do that. I think it's because we are already deleting that. Is that it? Maybe we can do something like this. Value cell count, right? And then E++. Well, we return. No, not really return. File. It's still too long. alpha tail value cell count. Oh, rather than using recursive, maybe we can use cell 0 cell I guess. Let me try that. It's an image rewrite from what? Image rewrite from scratch. Oh, that is awesome. I mean, yeah, I've tried Emacs previously and how customizable Emacs is, right? So, I mean, good luck with your project. I'm kind of interested to see the project though. I mean, again, I am interested in the text editor too, right? So if someone create a new text editor, well, I might want to check them out. Length 60. Okay. Head 69, 42 or 42, 69. Okay, interesting. Free this one, okay. Let me check. This one, right? I'll basically free the cell. This one, 69, 42, and then another cell. It is count 3. Oh, okay. I mean, the count can be ridiculous, right? So, okay, the count 3. We are freeing this, but cannot access. Okay, I think this free expression is correct. To prevent the, what is it called? The dangling commit. I mean, let's check this one out. Right, we are deleting the eval variable, right? So this one, okay. Alpha tail. This make me curious though, like, do we need this one? I mean, I don't think we need that one, right? Oh, right, no. Yeah, we need this one because it's like we are dereferencing the cell, right? If we take a look, cell is actually pointer of pointer. And that make me curious. Can we debug? Okay, and then let me check in GTP. Let's add breakpoint in this one. Run, okay. Line 6942. Okay. Print value cell. Right now, if I do, can I like do this? No. So yeah, we need to dereference using the subscript square bracket. I think that's the name, subscript. Yeah, I'm not really sure what is the name convention, right? Continue, okay. Alright, if you want to try it, you would have to first compile that. Oh, my game engine library. Then you can compile the editor because it uses my game Vulkan game engine to render. Oh, okay. Alright, so it is so you are using the Vulkan game engine for the text editor. Is that it? Okay. That is interesting. Yeah, I'm still new to this. What is it called? To this compiling ecosystem. No, not compiling ecosystem. To this like low-level programming, I guess. Maybe that's the word. Yeah, I'm still new to this low-level programming, so I cannot imagine how to use a game engine for the text editor yet, right? Maybe one day I will understand how to do that. So yeah, kudos to you, Lalo. That looks like an interesting project. And at my current, what is it called? At my current skill, I guess, that is way too advanced for me. Maybe one day I will be able to check that out and understand what is going on, right? But for now, let's create a simple Lisp interpreter first. One step at a time, right? Okay, okay, so we cannot do that, right? Okay, I think we can commit that. Yeah, let's commit this. We adding the length keyword in here, right? Or symbol. Oh, Is it in the expression? Yeah, we can use the number. Maybe. And then implement this line, right? Okay, wait a minute. Let me cross check. Okay, git commit. It is a feature, I guess. Add line implementation. Add line. Keyword to print out the numbers of, what is it called? The numbers of quote expression. Okay. Now we can use keyword line with expression to type how many expression there is. For example, line 6942, and then where is the head again? Which print out the total of 3, because we don't evaluate the head. Okay, 42 in quote expression, inside quote expression. Maybe I should also add a comment here. Keep in mind that we don't evaluate anything inside the expression. So if we provide the head, it will be treated as one expression, one item. Okay. wait, let me check again. Alright. Let me add this and then amend, no edit. Okay. Alright. Where is it again? This is it that is in the red, right? I mean, if it do something like this, it will print out like this. Is that it? Okay, we already compiled it with the bug. I want to check in this one. 4 to 9. Okay, break utils at a breakpoint to 4 to 9. Okay, then run 16 at 69. Oh, so sorry, it's not an executable. Break utils 4 to 9. Okay. Run. Head 69. Print this value. Okay. Count 9. Oh, okay, yeah, because the AST, right, that should be the one I take a look at. The AST, okay, this is the root, right? Chilton num. Let's continue first, I guess. Okay, continue. Run. Yes, wait. Okay, 69. I need to know what is it called. Content children regex. Okay. I mean, there is another. Oh. Okay. Well, you know what? Try to handle case head to right. Okay, case 16 and 42 to print out head 2942. On Spirit Mind. On Spirit Mind. Okay. Yeah, I'm kind of curious though, like what happen if we only print the number? Like, Okay, maybe we will try this out on the next session. So that's it for now. Thank you for watching and see you next time. Bye bye. Okay.